Hello everyone, and welcome to the first part of our intermediate webinar series, Making Figures with ggplot2, ggplot2 Basics. So in this section we're going to discuss what ggplot2 is, as well as some of the basic fundamental principles of it, before we move on to later sections in which I show you how to graph specific type of figures and customize your figures. So first we're going to talk about what ggplot2 is. I've included the link to ggplot2's website here for you to peruse at your own convenience. And ggplot2, simply put, as defined on their website, is a system for declaratively creating graphics based on the grammar of graphics. The grammar of graphics is actually a system for describing the individual components that make up a figure or graphic that we are visualizing, and that grammar is described in a textbook, which I have included a link to here. Now, by all means, the textbook is not necessary to understand ggplot2. It is merely the foundational principle for it. So ggplot2 allows you to build your plots layer by layer using code, and in this section we're going to go over the GM and AES layers specifically. We're going to review layers that allow for further customization in later sections. And for our example data, we're going to be using a table from the output of the Genome Assembly QC program, QAST. So we're going to start by reading in our table, storing it as a variable, and then viewing it. If you have seen our earlier webinar series on an introduction to R, you know that you can read in tables into variables in R using functions like read.table, read.csv. I'm going to use read.delim for this table, and I'll show you why in just a second. We're going to be including the parameters header equal true, because our data has a header, check name equals to false, which I'll discuss in a second, strings equal to factors equal to false, because we want our strings to be read as strings and not factors, and sep equal to tab, because our file is tab delimited. So we're going to store it as the variable df, and we're going to use the view function to view it. Now, as you can see, this table is set up where each row corresponds to a sample, and then the column corresponds to a particular QC metric for that sample. We have things like number of contigs, and this is why I chose to include read.delim as the function and not read.table. Read.table tends to throw errors if you have curious characters in the names, such as a hashtag or a parenthesis or a greater than sign or an equal sign. So I used read.delim for that purpose, and as you'll recall, I also mentioned the check names parameter. I chose that because I did not want R to alter the column names in any way, which are by default, if you do not set check.names equal to false, it will actually sanitize the headers to something that R can more easily interpret. So we have things like the number of contigs over a certain number of base pairs, the total length of the assembly over certain base pairs, the number of contigs in total, largest contig, total length, in 50, which is a common assembly QC metric, and then we have some metadata associated with these samples, such as species and antimicrobial resistance profile, which we're going to use in later figures. So the ggplot function shown here is the function for creating a new plot using ggplot2. As a reminder, we load a module into R using the library function, and we can use the question mark to view its documentation in the help tab. Alternatively, we can go into the help tab and manually browse for topics, but we're going to use the question mark. So let's load in the package and then use the question mark. And as you can see here in the help tab, this takes us straight to ggplot's documentation with the authors, and it includes some useful links as well. Let's go ahead and just pass our data frame to ggplot and see what happens. So what we see here in the plot tab is actually just this gray square. It actually has nothing in it, and that's because we have not given it a way to interpret our data. We've only passed it the data. And so this is where the GM and AES layers we'll be talking about today come into play when we're plotting figures with ggplot. Next, we're going to talk about GMs, which are geometric objects. They specify the type of graph we are plotting, whether that be a line graph, a bar graph, a scatter plot, etc. And you can use the help function to search for different types of geoms, and there are many that are available in ggplot2, or you can use, again, the search bar in the help tab. So let's use the help.search function with our search term being geom and the package equal to ggplot2. Now, what this pulls up is a list of many of the different geom functions that are available, whether that be geom bar, geom count, geom hex. There's many to choose from, and there's actually been a number of other packages that have been written to expand the number of geoms that are available in ggplot2, or to even give new functionality to different geoms that are present in ggplot2. Now, moving on to the AES function, which is also known as aesthetic mapping. We use the AES function to map variables to visual properties, such as the XY position of data, or the color, shape, and size. And remember, AES is a layer we add to our plot alongside our geom layer that we just discussed. And we do this by placing the AES function within the ggplot function. So for example, we're going to plot largest contig versus total length, where largest contig is the X variable and the total length is the Y variable without a geom layer first. And that gives us our X and Y axis, but no data on the graph. And that's exactly what we see here when we run this line of code, where we say our data frame is DF, we have our AES function, we set X equal to largest contig and Y equal to total length. Now, here on our plot, we have the axes we specified, but no data. And that's because we did not tell ggplot with a geom function the type of graph we wanted to plot the data as. So adding geom point to our graph of largest contig versus total length will plot a scatter plot of those data. And we add that with literally an addition sign. And now we have a scatter plot of our data. We have given ggplot everything it needs to give us a full graph. And if we wanted to plot those data as a line, we could use geom line instead. And now that data is visualized as a line. If we wanted to include both dots and lines, we can use both geom functions at once. And now we have our line plot with the individual data points represented as dots here on the graph. And you may have noticed that when I use the addition sign, I indent on the next line. That is personal preference. You could simply represent the data this way, where it's all in one line, or you can even press enter and get rid of the indent, and R will still be able to interpret it accordingly. It's really just visual preference. I like to keep to the rule that the code does not pass the maximum number of characters, which is represented here as this line in RStudio. But again, whatever is easiest for your eyes to read and whatever you find most convenient, it's up to you as the user. So we can change the appearance or aesthetic of our plots by adding more parameters to the AES function. The properties we can change using AES include things like shape, size, color, which is the outside color of our data, the outline, the fill, which is the inside color, and the line type. So if we want to make a uniform across the board change to the data we're visualizing, we make that change outside of the AES function. So for example, to change the color, size, and shape of the points of our plot, we're going to place all of those parameters within the geom function and not within the AES function. And that's what this looks like. I want to change the size equal to 3, which will make our dots larger. I'm going to change the shape equal to 17, which will change the shape from a circle. And I'm going to make the dots blue. And I do that by putting the word blue in parentheses. And I'll discuss it in a much later section, but we are going to go over how to change color palettes. We're just going to be sticking with the defaults for now and what's available in base R. So when we run this code, we see now that our data is plotted as points because we use the geom point function, but instead of black dots, we have large blue triangles. And we can do the same with our line plot by changing the color and line type. We're going to keep the changes we made to the geom point function above, and this time we're going to add some extra aesthetics to geom line. We're going to keep size equal to 2, but we're going to make the line type dashed, and we're going to make the color purple. And now here we have our line plot and dot plot here, where we have our large blue triangles and our purple dashed line. Now, these are obviously not the best aesthetic choices. This is not how I would be representing my data in a report or a publication. They are merely here to show you that you can make these aesthetic choices. And we can actually find the numbers associated with point shapes and line types by viewing them with a ggpubber, which is a R module command. And we're going to load in the ggpubber library, install it here if you have not installed it already. We're going to use the command show point shapes, and this will actually load in the point shapes available in R here into the plot section, and it will also do the same if we use the command show line types. You can also just go into Google and do a quick Google search for line types and point shapes available in R, and you'll find similar graphics that will give you the information for the different types of points and their corresponding numbers, as well as the different types of lines and their corresponding numbers, or rather, excuse me, names. So if we want to map an aesthetic change to a variable in our data set, we make that change inside of the AES function. And this is, again, not a uniform across the board change. It's to a specific variable that we want to represent in our data. So for example, to change the shape and color of the points in our scatter plot based on AMR profile, which is metadata we have, again, in our data frame all the way here on the right, we can do that. And we're going to start by, we've already looked at the data, so you could use the view function if you wanted to. But we're going to say that we're going to add an extra AES function within geoPoint, and we're going to say shape equal to AMR, which is the variable we want to represent. And when we plot that here, we can see in the plot tab that we have our same data represented, but this time the shapes of the points vary based on the corresponding AMR profile of the data. Where we have our BLA KPC3 positive samples represented as circles, our BLA OXA23 positive samples represented as triangles. I believe there's only one of those, so it's probably hidden here within this data, which is why we can't see it immediately. We have our BLA OXA23 and BLA NDM1 positive samples represented as squares, and we have our BLA OXA72 positive samples represented as pluses. We can do the same with color. So instead of choosing to represent the AMR profile by shape, we can do it by setting color equal to AMR, and we have the corresponding color changes mapped onto the data instead. And we can do the same for both color and shape by setting both color and shape equal to AMR. And in this case, I'm going to have the shape equals to species instead of AMR. And then what ggplot does is it will automatically give you a legend for both species and AMR, where it will show the shapes that correspond to the particular species, as well as the colors that correspond to the particular AMR profile. Now that's all I have for this section, but we're going to discuss how to customize these figures further in a later section. Thank you all for viewing, and I will see you in the next episode.